Hi, pause the video and try these questions. This is going to be a second lesson on perpendicular lines today, so we're just going to remind ourselves of some key facts to start with. Okay, here are the answers for the first question. So A and F, the gradients are negative reciprocals. Same goes for A and C, in fact, whereas C and F are parallel. And then the other pair is D and D, where you have a half and -2. So none of B by itself, like it's not parallel or perpendicular to any of them. This one here, which line is parallel to A? So we see it's going to be D because they have the same gradients. Which line is parallel to C? That's going to be B because they have the same gradients. And which line is perpendicular to B and C? They've kind of given away that B and C are parallel with that, but it's going to be the one with -1/2 because that is your negative reciprocal. And then finally, find the midpoint of these two. What we can do is we can do 0 plus 6 over 2, 2 plus 0 over 2. This is basically finding the mean of two numbers, which is the midpoint, and that will give us 3 and 1. Now here you can see it. You can see like what's a number that's halfway between 0 and 6? It's going to be 3, and the same with 2 and 0. But this is useful to know for more complicated questions. And if you had, say, fractions or decimals, you can just jump and use this formula. In general, it's x1 plus x2 over 2, y1 plus y2 over 2. And just a reminder, two lines are perpendicular, the product, that is when you multiply their gradients, you get -1. And then to get the gradient of a perpendicular line from if you have a line, the gradient of a line, and you want the perpendicular line, the gradient, then it's -1 over m, the negative reciprocal. Okay, today we're going to extend our understanding of the idea of perpendicular lines. And what I want you to do actually is have a go at this question, not using the graph, but by trying to do it algebraically. So pause the video, give it a go. If you're not sure, then listen on and I'll give you a bit of a hint, and then after that I'll go through it. So at this point, you should be confident, or at least like remember to recall to some extent the idea that if you're told that two lines are parallel and you're given the point at which that one of the lines goes through. So if you're like given that y equals 2x plus 3, and then you're told, well, there's a line that's parallel to that goes through such and such a point, then you should be able to calculate the equation of that new line because you know the gradient of it is going to be the same as the original line, and you know the point that it goes through. So this is just an extension of that. And here's what we do. So the perpendicular line is going to have not a gradient of 2, that would be for a parallel line, but a gradient of -1/2 because it's the negative reciprocal. By the way, sometimes this symbol is used for perpendicular, so I'm going to use it here for the perpendicular line. And then that is the main bit, so we can then write down that y is equal to -1/2 x plus c. And we're back to substituting in the point that we have. When x equals 2, y is equal to 6. So it must be that 6 is equal to -1 plus c, because -1/2 times 2 is -1, and therefore c is 7. And we are done. We've got m, we've got c, y is -1/2 x plus c. Now, I've drawn this graph just to kind of remind us how to draw graphs using y equals mx plus c, and also to demonstrate that it does work. So if we draw the original line, it's going to be 2x plus 3. That means it goes through here. I've got gradient of 2, so I'll go along 1 up 2, along 1 up 2. 3 points is enough. I could add more. I could go back 1 down 2, back 1 down 2. That gives me 5 points, and I can draw my line. Okay, that's the original line. And for my new line, I've got that it goes through 7, and then the gradient is minus a half. That means I go along 2, down 1, along 2, down 1, along 2, down 1 to there. And you could get a protractor and show that this angle is 90 degrees. Hopefully I've convinced you. We've done it algebraically, and then we've sketched, well, not sketched it, we plotted it, but using our knowledge of y equals mx plus c, and we see that in fact, yes, in fact, they are perpendicular. And that is the main bit from today's lesson. So what I want you to do now is try this one yourself. We've got the line n. Which one of these equations will be the line that's perpendicular to n that goes through 0, 1? Okay, so for this, it's going to be very similar. We're going to work out the gradient of the original line. It's going to be 3. So the perpendicular line will have a gradient of minus a third. Now in this case, because it goes through 0, 1, I basically get the intercept for 3. It's going to be, it's got to be 1, and the gradient's minus a third, so it's got to be c. You might have written it as, so basically I could have written minus a third, I could have at this point written y equals minus a third x, because I've got the gradient, plus 1, because I basically get the intercept for 3, and then I can see it's the same as that answer C. So try some more yourselves now. They're similar kinds of questions, except they start linking into other aspects of this topic here. So you're not given the gradient of the line quite so easily as in part A. You have to figure it out. But if you've got that understanding about rearranging, it's practicing that skill, but now combining it with perpendicular lines as well. So hopefully you had a good go. Here are the answers. Okay, A to J. Pretty sure they're all correct. Check them. Check that you are happy with this topic. This is a more challenging, but I got to say, an amazing application of y equals mx plus c and perpendicular lines. Being able to use algebra to calculate the perpendicular bisector. Just going to remind you what that means. It means if I have the points 0, 2, so it will be here, and 6, 0 here, how can I draw a line that splits? Essentially, I'm going to draw the line in. It doesn't say to do that, but essentially splits this line into 2 and is perpendicular to it. So in the past, you should have done this with a ruler and compass. I've created a compass. It's just right at the top of the screen. And I'm just going to remind you about this, and then we'll do it algebraically and see that we don't need a ruler and compass. We can do it exactly without. So what we do is we put 1 point on there, we go a bit beyond halfway, and then we draw some arcs. And I do the same with the point on the other end, not on that end, on that end, sorry. Do the same thing. Mathematically, it must be that this point here is the same distance away from both points, and so is this one. So when you join it up, you create a shape that would be such that this line is 90 degrees to the original line and splits it into 2. That's how you can do a perpendicular bisector. We're going to do it, however, like imagining that we don't have this graph, so I'm actually going to cover it up for the moment. I just wanted to remind you what it was, and then we'll see if it works out. So first things first. Actually, let's you need to do this question by kind of visualizing it, and we want something that goes through the middle. So the first thing to do is find the midpoint, and this is actually something we did at the start of this lesson. You just find the kind of the average, or I should say the mean, as like the first two values. It's going to be 3, and then the second two values we're going to get 1. So we've got the point that our line is going through. And to be honest, that's the only new bit in this question, because now we're just finding a line that's perpendicular to another line that goes through a certain point. So let's find m for the gradient of original line, like the one going between these two. It doesn't actually say to draw a line, but I'm still going to treat it like that. That's going to be, I'm going to go with this as y2, so it's 0 minus 2 over 6 minus 0. I'm going to get minus 2 over 6. I'm going to get minus a third. So m equals 3 for perpendicular bisector. I've jumped straight in. I've just taken the negative reciprocal. And now I have the gradient and a point that it goes through, and that's all I need. This is back to what we've been doing. Y is equal to 3x plus c. I'm running out of space. I'm just going to substitute it in. When x is 3, y is 1. So 1 is equal to 9 plus c, and c is equal to minus 8. And algebraically, we have figured out the perpendicular bisector. Y equals 3x minus 8. If we look back at the graph, I didn't actually extend it all the way, did I? But I'm going to kind of cheat now a little bit, because like when we're doing it, by hand, we can make little mistakes, but I think it should be that. And then you can see, indeed, it does work. We can now calculate perpendicular bisectors given 2 coordinates. So I want you to try this one yourself, and then try the next few challenges as well. But if you're happy with that, this is going maybe a bit beyond what's expected. This is like the next level up, but make sure you are prepared for it, because you could be asked this sort of question. It's all about developing your understanding. I'd say the main thing from this lesson is the earlier question. If you're given a line and you can work out the gradient and a point, make sure you can do that. Make sure you can do ones where you can rearrange and get the gradient and then deal with the point. This is taking it a bit further. Here you have to have this understanding that you're finding the midpoint to get a point, then you're finding the gradient between the 2 points, then you're doing this extra perpendicular gradient, and then using that with the midpoints in it. So there's a lot going on, but yeah, practice it here. Okay, here's the answer. You get the midpoint. That tells you the point at which your perpendicular line is going to go through. You get the gradient between those 2 points. You take the negative reciprocal, it's going to be minus a half. So it's going to be y is minus a half x plus c. You substitute your midpoint in, and this is what we get. Another challenge. So in this case, it's slightly different. We're not using the midpoint. We're not finding the perpendicular bisector. We're finding the perpendicular that goes through a point. In some sense, this is a bit easier. It's just that when you've thrown this after doing the bisector, it can be a bit confusing. But we're basically finding the equation of this line here. So get the gradient between a and b, which can be done. It's going to be, I'm going along 2 and up 4, so it's going to be 2. Y is equal to 2x plus 4. We don't need to know that, but we need to know the gradient is 2. So the perpendicular gradient is going to be minus a half, so it's going to be y is minus a half x plus c, little c. Substitute your point in, and this is what we get. Okay, next challenge. Find the equation of the line which passes through the intersection point of the lines y is equal to x plus 3 and y is equal to 11 minus 3x, and is parallel to this. I'm going to show you the answer. I'm going to talk through this one. First things first is you need to get the intersection point, and this can be done by remembering that you've got a straight line here and a straight line here, for example, and where they intersect, the y values are the same. So we can set these equal to one another. X plus 3 equals 11 minus 3x. We can solve that and it will give x is equal to 2. You can substitute it back in and it will give y is equal to 5. So we've worked out where the lines meet, and that's important. And then we want a line that's parallel to this line. So that's going to be when y is equal to minus x plus 2. So now we know that the line we're interested in is going to be minus x plus c. It's going to have the same gradients. I know the point that it's going to go through, so we're back to that topic, substituting in when we know the gradient, and we know the point, and we can work out that c is 7. And this one here, there's a lot going on in this question, and it's really important to just label the key things. Some things are already labeled, like the fact that it's a square, so you know all these lengths are the same. That's worth adding on. P and D are points on the y-axis. We can see that PAB is a straight line that could be useful in an equation, the line that passes through the points A and D. So that is this line here is y is equal to minus 2x plus 6. Let me just write that again. So there's actually a number of ways of doing this question. I'm going to just show you the answer and the mark scheme. So the answer is 7.5. You could do this question by working out line BP, which is perpendicular. You could work out the coordinate for A using y equals 2x plus 6. It's going to be 3, 0. And then you can work out the equation of the line. You can work out P, and then you can work out the distance. That's one way. A second way is actually you can use similar triangles. This I wouldn't have thought to use that, but this triangle here, I believe, will be similar to this one in green, because this is a right angle. That will happen. I'm not going to go any more into that one. And the other way you can do it is you could, because we've got a right angle triangle, use Pythagoras' theorem, and if you can work out this length, then you could find the hypotenuse. I'd say the first method, I like this the most, but you know, it's actually good to see sometimes the fact that maths problems can be done in many different ways. We'll stop there. So hopefully you're happy with these questions on perpendicular lines. They've got increasingly more difficult, but the main thing is to remember you take the negative reciprocal, and then we use our knowledge of all these other areas of maths to help us with questions like this or perpendicular bisectors. So well done. This is one of the hardest topics on y equals mx plus c. So hopefully you're happy, or you're understanding a lot of it. Okay, keep going.